Well, dear students, in this video I am going to solve some questions based on rate of radioactivity, half-life, etc. There is a question here, a 280 days old, 280 days old radioactive sample has activity 6000 decay per second. After next 140 days, the rate of decay is reduced to 3000 decay per second. So the original means 280 days before 280 days original rate of activity option A is 9000 decay per second. 9000 decay per second. B 12,000 decay per second. C 20,000 decay per second, and C D 24,000 decay per second. So what is the correct answer to this? Here lies the answers. From present at present, यानी कि after 2 days, the rate of decay 6000 reduced to this half in 140 days. So since decay rate is reduced to half in 140 days, so T half 140 days. Half life of given sample is and since 280 days equal to 2 half lives, so RT upon R0 equal to 1 upon 2 the power n is number of half lives. RT 6000, R0 you need to find out. RT 6000, R0 you need to find out 1 upon 2 the power 2, n equal to 2 here. So R0 comes 6000 into 4, so it is 24,000. D option is correct. By here solution simple. After next 140 days, rate reduced to half. So half life is 140 days. 280 days, 2 half lives, and that's all. Question is over. Now next question here. There are two radioactive samples in a given radioactive material, A and B. The half-lives are T and 5T. For A, the half-life T, and for B, mean life. 80. Now plots are made total number of radioactive nuclei as function of time t as a graph of n and t like this. B graph is like this, n and t. C graph is like this, and D is, actually we know nt is equal to n0 e to the power minus lambda t. Here it is nt, rate of active nuclei left. So on an average the graph will come out like this. These are all the three absurd. So this is correct answer. Now next question is very good question here. And these two questions, first one was asked in 2004 JE. This one was asked in JE 2001. Now question next is in NEET 2017. What is the question? There are two radioisotopes, radioactive element A and B. A has decay constant A lambda, B has decay constant lambda. There are two radioactive elements A and B. Decay constant of A is 8 lambda, that of B is lambda. And you are asked after what time the ratio of number of Na upon Nb is equal to 1 upon E after how much time? If these two elements show radioactivity with the decay constant 8 lambda and lambda, then after how much time the radioactive nuclei left of A and B are in the ratio 1:E. So for Na, initially both have same number and the radio product are stable. Initially A and B have equal number of radioactive nuclei. So Na equal to e to the power minus 8 lambda t, and Nb equal to N0 e to the power of minus lambda t. Na upon Nb is equal to e to the power minus 7 lambda. But this divide करेंगे तो ये पाएंगे minus 8 lambda t minus lambda t, तो 7 lambda. And this ratio is 1 upon E given. 1 upon E equal to e to the power minus lambda t, 7 lambda t, or E equal to e to the power 7 lambda t. Comparing the powers, here power is 1, it is this. If two sides are equal, means their power are equal, base same. So 7 lambda t is equal to 1, so t is equal to 1 by 7 lambda. Here the options are given like this: 1 upon lambda, B 1 upon 7 lambda, C 1 upon 8 lambda, D 1 upon 9 lambda. So 1 upon 7 lambda is the correct answer. This question has been asked in NEET 2017. I hope you will be getting the solution. Now next question again is a good question here and has been asked in JE Mains 2017. JE Mains 2017. Question is there: radioactive nucleus A, half-life T, decay into B. A element is there, it decay into B, half-life T. Initially, there is no B, it has total A nuclei. So you are asked, at some time T, the ratio of number B to number of A is 0.3. Then T is given after time. Answer है T, A option. T equal to capital T upon 1.3. B answer is there. T equal to T log 2 upon 2 log 1.3. And C answer is there. T equal to T log 1.3 upon log 2. And D option is there. T equal to capital T log 1.3. So ratio of radioactive nuclei B and A after some time T is found to be 0.3. So at T equal to 0, let it be N0, and it was 0. After at T it will be N, then B will be N0 minus N. If by N atoms, initially it was having N0 atoms. It was having 0. If N atoms are left, then number of B will be N0 minus N. Here it is something difficult by student to understand this thing. Okay, left, N is the left nuclei. तो N0 में से N बचे रहेंगे, तो N minus N0 has become, and we are given that N0 minus N upon N is equal to 0.3. So N0 minus N is equal to 0.3 N, and N0 is equal to 1.3 N. Now, for element A, we know what do we know? K Nt equal to N0 e to the power 1 lambda t. So Nt is N, or it is N0 and therefore N upon N0 it is 1 lambda t. But it is 1 upon 1.3. रिवर्स करते हैं इसका N0 upon N है यहाँ पर 1.3, तो it is e to the power minus lambda t, और 1.3 equal to e to the power lambda. यहाँ प्रॉब्लम क्या है भाई, इसको हम लिख सकते हैं 1 upon, if we divide and therefore log of 1.3 on base E is equal to lambda t. Lambda, you know, 0.693 upon t half is t. And you know, this is what? These are the techniques. It is also log base E 1.2 upon t into t, or t equal to 2 into log base E 1.3 upon log base E 2. Sorry, it is 2 here, sorry. It is log 2 on base E. But in answer base log base E is not there, it is base 10 there. In every option base 10 is there. So if we convert that into log base 10, so 2.3 here, 2.360 here, so it becomes t equal to t log 1.3 upon log 2. So this is the correct answer. So such questions make you troublesome, so difficult. नहीं भाई इतना तो that much you have to do if you want to be different from others. You want to achieve higher caliber, and caliber can be improved by practice, nothing else. Everything is difficult, but some people keep on trying and they get it. Just now I got one video in which a child is trying to go on a table. So he tried 5 times and then he got. So try makes you win the game. Now next question here is there. Half-life of radioactive substance is 20 minutes. T half, 20 minutes. Don't take T by 2, T half. Just to understand it is half-life. It is 20 minutes. The approximate interval T2 minus T1 between T2 when 2 by 3 of it has decayed, and T1 when 1/3 of it has decayed. So T2 minus T1, you have to find out T2 minus. What is T2 time? The T time is that at which 1/2 of material has decayed. T1 1/3 has decayed. तो T2 minus T1 क्या होगा? Option A is there. Option A is 28 minutes. B is 7 minutes. C is 14 minutes, and D is 20 minutes. देखो T2 is the time when, देखो हमारा जो NT equal to N0 e to the power मान lambda T है. NT are the number of radioactive elements left undecayed. So at time T2 number of radioactive elements which have decayed 2 by 3, so left undecayed 1 by 3. So for T2 we can write 1 upon 3 equal to e to the power minus lambda T2. Here for T2 1/3 decayed, so 2/3 left undecayed. 2 by 3 equal to e to the power minus lambda T1. So this divided by this, 1 or 2. 2 divided by 1, 2 by 3 upon 1 by 3 is equal to e to the power, this divided by this तो पॉजिटिव हो जाएगा, तो लैम्डा t2 माइनस t1 कैंसिल, तो 2 is equal to e to the power lambda t2 minus t1, and therefore log of 2 on base e is equal to lambda into t2 minus t1. Lambda 0.693 upon t 20 minutes is equal to t2 minus t1. It is base 2, log base 2 is the cancel 1. So 1 equal to t2 minus t1 upon 20. So t2 minus t1 is 20 minutes. t2 minus t1 is equal to 20 minutes. So D option is correct. I hope you have got all these questions well. Please make the note of these questions. Where you don't get, please pause the video, write the question, and then try to solve it. Thank you.